On August 12, 2026, the Moon's shadow will race across the North Atlantic toward Europe. From space, the path looks clean and predictable, a moving mark crossing clouds, ocean, and the curve of Earth. For most people, it will be a rare celestial event. The shadow will touch Greenland, sweep near Iceland, and reach Western Europe, where daylight will briefly fall away as if the day has been interrupted. The sun will become a black circle in the sky, surrounded by a pale white crown. That glowing corona is normally hidden by sunlight, but totality reveals it for a few unforgettable minutes. But in this story, something impossible happens. The eclipse reaches its deepest point, the moon covers the sun, the world holds its breath. And then the shadow does not move on, it stops. At first, no one understands what they are seeing. Iceland's coastline sits under a frozen totality. The sea darkens, the clouds lose their daytime color, and the horizon keeps glowing without bringing daylight back. Above Spain, the sun remains covered, the sky stays blue-black. Streetlights begin to glow against the evening horizon, but this is not sunset. The black sun is still fixed in place. The first explanation is a software error. Then every telescope, satellite and camera says the same thing. The problem is not the data. The impossible event is happening in the sky itself. A moving planet now carries a stationary wound of darkness across its surface. Earth continues to turn, clouds continue to drift, but the eclipse shadow remains locked where it should never stay. Under real physics, this cannot happen. The moon's shadow moves because Earth rotates and the moon orbits. Totality is brief because every part of the eclipse system is constantly in motion. For the shadow to stop, something about space, motion, or time itself would have to break. It would mean the geometry of the sun, moon, and Earth had stopped obeying the rules we depend on. But if the impossible did happen, the first effects would be real, measurable, and immediate. Cities inside the frozen shadow would not simply look strange. Their energy systems, weather patterns, and living creatures would begin responding. Solar farms inside the darkness would lose output, as if sunset had arrived in the middle of the day. Control rooms would see production fall while demand patterns changed, forcing operators to balance power in real time. With sunlight removed, surfaces would begin to cool. Roads, rooftops, fields, and water would stop absorbing solar heat. The change would not be instant, but every exposed surface would begin losing warmth. Air near the surface would respond more slowly, but the change would spread through the lower atmosphere. Gentle winds could shift as cool air settled beneath warmer surroundings, creating a strange local weather experiment. Animals would notice before we fully understood it. Light is one of the oldest clocks on Earth. Birds, insects, and mammals use brightness to decide when to feed, hide, move, and sleep. During real eclipses, birds and other animals have shown changes in behavior when daylight suddenly fades. A frozen eclipse would turn that brief confusion into something longer, stranger, and far more disruptive. Even the edge of totality is not smooth. Sunlight leaks through lunar valleys as bright beads before the sun disappears. These last flashes remind us that the moon is not a perfect circle, but a rugged world. Then, after hours of impossible stillness, the edge of the shadow begins to move. A thin tremble appears across the boundary, as if reality is loosening its grip on the frozen eclipse. Light returns slowly, not like sunrise, but like a machine restarting after a failure no one can explain. Streetlights switch off one by one, birds lift from rooftops, and cities remember daylight. The shadow releases Europe. From orbit, the dark patch slides away toward the Atlantic. The planet continues turning, the atmosphere brightens, and the impossible moment becomes something history will never forget. But the event leaves behind a deeper truth. Total eclipses themselves are temporary. Even without impossible physics, Earth is living through a rare age in the long story of the sky. The moon is slowly moving away from Earth. One day, it will appear too small to completely cover the sun. Future eclipses will become rings of fire instead of perfect darkness. Earth lives in a brief cosmic age when one world can perfectly hide a star. Ancient skies, modern totality, and future ring eclipses are all connected by slow celestial motion. Every eclipse is not just a shadow. It is a reminder that our sky depends on an extraordinary balance of distance, size, gravity, and motion. A balance beautiful precisely because it cannot last forever. Far above the ground, Earth's ionosphere would also begin to change. This upper atmospheric layer is charged by sunlight, and when sunlight suddenly drops, its structure can shift in ways instruments can detect. That charged layer helps radio signals travel. During an eclipse, parts of it weaken or reorganize, causing radio waves to bend differently. In a frozen shadow, the effect would no longer be just a momentary curiosity. In a normal eclipse, the ionosphere recovers as sunlight returns. But a frozen shadow would turn a brief experiment into a planetary stress test, stretching temporary changes across communication systems, satellites, and scientific monitoring. The frightening part would not be darkness itself. Humans understand night. What would terrify the world is the fact that the sky had stopped keeping time, and nobody could explain why. A solar eclipse is not night, it is a shadow, a narrow cone cast by the moon onto Earth. Inside the darkest part, the sun is blocked almost perfectly, but only along a thin, moving path. Totality is brief, because nothing in the system is still. Earth spins, the moon moves. The shadow sweeps onward like a needle crossing the planet, fast enough that total darkness usually lasts only minutes. The shadow's path is the result of a moving moon, a rotating Earth, and a star almost perfectly aligned behind it. Change any one part of that motion and the path changes too. And that perfect covering is a cosmic coincidence. The sun is far larger than the moon, but also far more distant. From Earth, for now, they can appear almost exactly the same size.